right, indicator 7.2 is graphing vertical and horizontal lines. So let's skip past, this is all review from yesterday. And we're going to look at number 5 and number 7. Okay, number 5 and number 7 here. And so I'll leave them up there for just a sec so you can sketch them out real quick. Well, let me, there we go. Y equals 1 and X equals 1. All right, so if we look at number 5, obviously these are special cases because we're used to seeing all of our linear equations thus far, remember, have had a generic X and a generic Y. They've had both. And all of our lines, depending on whether it's a positive or a negative slope, have been slanted in some way, shape, or form, uphill, downhill. Sometimes they've been really gradual slopes. Sometimes they've been really harsh slopes. But either way, there's always been some sort of slant, some sort of rise over run. Well, X equals and Y equals are special cases. So Y equals are always horizontal. Y equals are always horizontal. Okay. Think Y's sunrise, and think about your horizon. When you're looking at the sunrise, which direction does your horizon run? It runs this way, right? So Y horizon always is going to run this way. And the way you graph it is you have Y equals 1. That means on the Y axis at the positive 1, you are going to put a point. And then think, like I said, Y horizon. Okay, your line is going to run like a horizon right through your point that you just plotted. And notice there is no, remember I said linear equations have a generic X and a generic Y. Okay, this doesn't have an X. Okay, it's never going to go through the X axis. Okay, I shouldn't say never. There's one special case. We'll talk about that at the end. But you'll notice it doesn't go toward the X axis. There are no X's. It's just Y's. Okay, it's always Y of 1. And we need to talk about the slope of these special lines. So if we think of slope, right, as rise over run, we know that. If I were to put, and you can put it anywhere on this line, I'm just going to pick a point. I'm going to put another point on this line, okay, because you have to have 2 points to think about slope. If I look from my red point to my purple point, what is my rise? 0. I don't rise at all, right? So my rise or my change in Y's is 0. And then what's my run on this particular red to purple? What's my run? Yes, ma'am. 4. What does anything with 0 on top reduce to? 0. The slope of every horizontal line is 0 forever and always. It doesn't matter where it's at on the graph. The slope of every horizontal line is 0. And you don't have to do this math right here. Okay. If I ask you the slope of number 6, slope equals 0 every time. Okay. And the kind of the silly memory trick for that is 1, there's a Z in horizontal, Z0 horizontal. Okay. The other one, my college algebra teacher showed me this and I just thought it was cool. If you write 2 horizontal lines, they make a Z. Stands for 0. Okay. That's just a way to remember that your horizontal lines are always going to have a 0 slope. Okay. You don't need this other example in your notes. I'm going to do another example of a Y. So I'm going to go to the Y axis, right? And it's Y equals 3. I'm going to put a point right at 3. Think Y horizon. Your Y's always look like a horizon. They always go left to right. And that's it. It's graphed. You don't have to state your M, your B. You don't have, you don't have any of that. You don't have anything to do except for just simply put the line. The challenge of this section, if it's challenge at all, but the challenge of this section is just remember Y's are horizontal and X's go up and down. Okay, so let's look at my X. Well, first of all, it's called a vertical line. Okay, is the technical term for it. And now we switch gears and we've got x equals 1. So now you got to concentrate on your x-axis. At x equals 1, you put a point, x's go up and down. And that's it, it's graphed. You put a point on the x-axis where it tells you to put a point, and then you just draw an up and down. Y is a horizon, x's go up and down. Okay, if you've got that, you're good. Let's talk about the slope of this. Again, slope is rise over run. If I put just a random point here, anywhere, what's my rise here? Anybody from blue to purple? Yes, Logan? 4. Okay, what's my run from blue to purple? What's my run? Go ahead. Logan? 0. Can you have a 0 in math? In the bottom of a fraction. That is a math foul. Your answer is undefined or no slope. I just want you to get used to seeing it both ways. Undefined or no slope. Again, you don't have to do the math of 4 over 0. You just simply, if you're asked the slope of x equals -4, slope is undefined. Okay, no math needed on either case. As long as you can remember the memory trick, you don't have to do any math of finding your rise over run. Okay. And the memory trick that my algebra teacher showed me is if you write 2 vertical lines together, they make an N for no slope or undefined. Okay. So again, you only need one example in your notes, but here if I have x equals -4, again, x-axis, it's x equals -4, put a point, x's go up and down, and it's graphed. These are super simple to graph, super quick to graph. Like I said, the challenge is remembering y is horizon, x's go up and down. Okay, now I do want to, these are the special, I do want to call these kind of the special note here. Number 9. Everybody wants to look at these and think that's weird, right? There's no other numbers, so it must be a horizontal or a vertical. If there is an X and a Y, it's never going to be horizontal or vertical. The only time it's horizontal or vertical is when there's only an X or only a Y. If you ever have both, you're always going to have some sort of slant and some sort of Y intercept. So we just need to fill in the blank of what's there, but it's not there. There's really a 1 here, right? And there's really a +0. So our M here is 1 over 1, and our B here is 0. So when it looks like this, just a plain y equals x, that is still a sloped linear. It's not one of our special cases. It just looks special because it's really missing a lot. So we graph it by putting our intercept right at the axis, and then our slope is just simply up 1 over 1, up 1 over 1. And that's that line, right? Notice it's not a special one that goes straight up and down or side to side. It does have a slant to it. It just goes through the origin, which is fine. And its slope is 1 over 1. Okay, now what about when you have just a y equals 0? What's that going to look like? Well, if you can remember that y equals 0, well, the point's going to be at the origin, but we have to remember that y's are horizons, right? So y's go this way. So while it sits right on the axis, it still has to go horizon. It still has to go horizontal. Okay. And I'll do these in different colors because I'm going to do them on the same graph. So y's are always going to be horizontal or horizon. They're always going to go side to side. Now, if you look at the x equals 0, the point is still going to be at the origin, but x's go up and down, which means x equals 0 is going to go up and down right at the origin. So no matter what the y equals, it should always go side to side. No matter what the x equals, it should always go up and down. Okay? Are we good? All right. For those of you at home, click load on the Cami button and show all your work and email me if you have any questions.